it's the technology that can convert heat into electricity. Nowadays, we need like something like smart farm.
The future of thermoelectric.
If we can increase it more, then it will become competitive to other technologies. For example,
hello, and welcome to this podcast brought to you by KKU Academy. I'm Duncan Foster. I'm a lecturer at Konkane University in Performing Arts and a consultant here at KKU Academy. We're very pleased to have with us today Professor Supri Pinitsuthon, who is an award-winning lecturer in the Department of Physics in the Faculty of Sciences here at Konkane University. Supri, if I may use your first name, would you like to begin by just introducing yourself? And just perhaps you could just tell us your main field of work.
Oh, hi everyone. My name is Supri Pinitsuthon. Okay, so my main research is on thermoelectric. Or thermoelectric materials.
Okay, so when I first heard about this, I heard, well, that's really interesting. That sounds easy. Thermoelectric and that means thermo, heat, electricity. But then when I thought about it, I thought, actually, I don't know what that is. So perhaps we could begin with a brief description of thermoelectrics, what it is.
Thermoelectric consists of two words. You just say thermo and electric. So it means that it's the technology that can convert heat into electricity.
Yes.
So imagine like we have something, and we have one side is hot, one side is cold. Then what happens is the electron from the hot side will move from the hot side to the cold side. And when electron moves, it creates electricity.
Because electricity is electrons moving. Yes, I remember that much. Okay.
So that's thermoelectric. So when we get hot side and cold side, we create electricity or voltage. We call this Seebeck effect. And this is one mode of thermoelectric, which is we call the generator mode.
Generator mode.
Yes, generator meaning we generate electricity. That's generator. And there is another mode of thermoelectric, which is the cooling mode.
Cooling.
Yes. So we reverse the effect. So instead of input the hot side and cold side, we input the electricity.
Okay.
And then what happened is that from the piece of materials, which is like at a normal temperature, we create one side is hot, one side is cold. And we use the cold side for cooling.
Yes. But that sounds... It almost sounds too good to be true. So you just need a hot and cold, and you'll start electricity, and vice versa. So I suppose the question that jumps to mind: why isn't that solving all the problems of the universe? In the sense it sounds as I say too good to be true. Almost.
Yes, but the thing is, the efficiency is quite low at the moment, because if you imagine, what we need is that we need something that that electrons can move through very good, which happens in something like metal, like this. But we need to separate the hot side and cold side. So we need something thermo-insulative, meaning the heat does not come from the hot to the cold side, which happens in something like wood or glass.
Yes.
But so the metals, electron conducts very well, but it also conducts heat very well as well.
Yes. Okay.
But for wood, it blocks the heat. It also blocks the electron. So the materials that is good thermoelectric doesn't really exist in the world. So we have to synthesize it.
Okay. So if I get that right, you need something that conducts the electricity.
Yes,
the electricity can move. The electrons can move easily. So it cuts that, but doesn't conduct the heat.
Yes.
And that's not something we can just go and find easily. Okay.
Exactly.
So what's your particular passion in this field then? Is that...
Okay. Because the efficiency is so low.
Yes.
So what we have to do is to understand how to control the electron and how to control the heat production. So we have to separate the electron from the heat. and then engineer the structure of the materials using many things like physics, chemistry, engineering, nanotechnology.
Okay, and so we're talking at a very, very small level. You're working.
Yes. So the materials, the piece of the thermoelectric is large, like this, but we have to understand what is inside the materials at the nano levels, atomic level.
Okay, that's fascinating. Yeah. Okay. So I see. So, is there some way that we might meet this in our daily lives?
Yeah. So, because the efficiency is quite low, as I told you, not many applications in daily life you will see, but because originally this thermoelectric technologies was created for the space technology.
Ah.
Yes.
Okay.
So in the spacecraft, you go out of the world to like the NASA Voyager, meaning going out of the solar system. So there you have no sunlight. Okay, out of the solar system.
Mm-hmm.
So, but the spacecraft need some electrical power to power its electronics. Yeah, and they use the thermoelectric generator for that. So to create cold side, it's easy because in the space it's so cold. But to create the hot side, they use the radioactive material, which decays and then emit some heat for the generator.
I see. And what amounts of electricity are we talking about? Does it require a lot? Is it just to power it?
Yeah, it's enough for the spacecraft. And another one is I don't remember the name, but the spacecraft to Mars. Yeah. And they also use this.
Oh, so those were projects that started quite a while ago.
Yes, like 50 years ago.
Oh, so it's not really a new
it's
concept.
Not new, but it is so reliable that 50 years ago in the space without maintenance, and it's still working at the moment.
So the efficiency is very low, which is a problem, but it's very reliable, which is
so the thing is, we use thermoelectric in a place where we don't have other choice, not much choice, like in the space.
Yeah.
And another application is that they use in the volcano. So
in a volcano?
Volcano, yes. Okay. In the volcano, you need some sensors to sense if the volcano will be erupt whenever it erupts. Okay. But this sensor needs some power supply, and they will use thermoelectric for that.
You have a lot of heat.
Yeah, heat and the cold side. Yes.
Where does the cold come from?
Well, volcano is the top of the mountain.
Yeah.
So it's really high altitude. So the temperature is quite cold, low, and inside the ground is heat. Yes.
You talked to me once about using it on the farms as well.
Oh, yes. So nowadays we need like something like smart farm.
Smart farms.
Yeah, smart farm meaning the farm that can tell us when the humidity of the weather, the ground soil, and other things. So they need the sensors to measure this. And this sensor also needs the power supply for that, which thermoelectric can be the answer.
Okay.
But we're talking about the generator.
Yes.
For daily life, as you asked, it's more about the cooling.
Mm-hmm.
So the cooling mode, it's more on the cooling mode. We have
so you would put in electricity, and produce a cooling effect.
Yes. We have the thermoelectric cooler, which you can buy on Amazon, something like that. It's a kind of a box like a normal cooler, but you have to plug in the 12-volt DC like in your car. So it's more like the box when you travel for picnic, for outdoor activities. So and you have your beers, your Coke, and other things.
Okay.
Yeah.
And finally, we got to a use I can use.
And are you a gamer?
Yeah, occasionally.
Yeah, playing game on mobile phone. Yeah. So when you play your game on a phone, your phone becomes really hot.
Yes.
Right?
Yes.
And they have the thermoelectric cooler. You can find it online to put on the back of your phone, make it cool, and your game you can play it smoothly.
Okay.
Yeah.
Great.
So cool.
Okay. So that's got quite a wide number of uses. Just finding when is the right place to use it. So to go back to what you are working on, I think you understand you're working on trying to find the right materials.
Yes.
So what's the process in brief to go about to find that material?
Okay, so I'm working mainly on the generator to produce electricity. Okay. So in this field, there are like different kinds of heat that you have to consider. For example, heat at room temperature, our body heat, and heat in the oven.
Okay.
Yeah, that's like several hundred degrees C. So I'm working on the room temperature heat because nowadays it's only one or two materials which are in the field. And I'm trying to improve another kind of material.
Well, I know it's probably difficult to explain to people like me, but how do you find a new material? What do you do? How do you start doing that?
So I'm not a person who really find it. There are like other researchers who find these materials, and we, the thermoelectric community in the world. So we like have the conference to exchange the ideas, looking at the papers, and then we study. And like some people would have theory that if you do this, do that, you can improve the materials, improve the efficiency of the conversion of the heat to electricity.
So you're a thinker. You're thinking.
Yeah, I think and I design, and then we experiment in the lab.
It's interesting you mentioned world conferences, because here we are in Khon Kaen.
Oh, yes.
Quite far from Bangkok, which is quite far from New York and London and Shanghai or wherever. Why Khon Kaen? Why?
Okay, why I start working at Khon Kaen? Actually, I grew up here.
Okay.
At Khon Kaen.
That's a good reason.
Yeah. So I study at Khon Kaen University for my bachelor degree in physics here.
Okay.
Yeah. And then I study my master and PhD in the UK. And then, I got the Thai government scholarship. And then after that, I decided, okay, let's go home. So I come back home.
So is it now, because I guess because of communications, the advancing communications, you can be somewhere with respect to Khon Kaen, where I live and work. Now, you can be far away from the main hubs of knowledge or science or whatever, and still partake fully in the research in that world.
Well, yes, but I can do that. But at Khon Kaen University, thermoelectric, I started from I can say zero. Yeah.
Oh, so so it's here because you're here. I'm asking the wrong question. It's not why are you here. It's thermoelectrics is here because of you.
Yeah, we had one PhD student before me working on the thermoelectric, but the lab he has to do it abroad because we have no equipment. Yeah, so I started like 16 years ago. And try like purchasing new equipment and bring new students in and develop the lab.
So what would you say would be one or two of the highlights of your career so far?
Okay, so as I just mentioned, I'm so proud that I built the thermoelectric lab at Khon Kaen University. And
the lab here.
The lab here. And so I acquired like funding to buy instruments and recruit new students. And we are now, I can say, like the best lab in thermoelectric in Thailand.
Great.
Yes. So
so I was completely wrong asking why here, because here's the place. You've made this to be the place.
Yeah. So I received the award from the KKU. And it's called I received the Sarasin Honorary Award, which is the highest rank for the research award for researcher or lecturer in KKU.
I see.
And this year also got awarded from the National Council of Research Thailand. For the research award that I've been doing on this field, thermoelectric.
May I ask where your funding generally comes from? Who's interested in this field? Is it governments or?
Yeah, so mostly governmental funding. The thing in Thailand is that we don't have the company who do thermoelectric at the moment. Yeah. So that's the difficult thing to get funding from industry.
Oh, fascinating. Okay, great. If someone was watching this and thinking, well, that sounds an interesting field, perhaps they're studying physics or not yet, what would be the direction for them to follow? Where could they find out more? What career path would they follow?
Oh yeah, if in Thailand, it's me.
It's you. Okay.
Yeah, at Khon Kaen University. Yeah,
okay.
You can contact me directly.
Okay, fine. Well, we'll put up, if that's okay, we'll put up your contact details. Yeah, sure. Oh, so if anyone's interested, just contact you.
Yes,
and
fine. Exactly.
Excellent. I'm just wondering, somebody works like you do, so I assume intensely on this. What's your kind of approach to work-life balance? Is this something that consumes you all the time, or?
Well, before this year, I was okay, but now I become the head of the department. Okay. So more the administrative work. Yeah. So that's a little bit more busy for me. But the thing is, I come to work quite early because I have to send my kids to school at 8 before 8. So I come at 8 to work. But I finish work, I would say on time because I have to pick up my kids at school. So 4:30 at the latest. And then after go back home, I don't usually work.
Okay.
Yeah, I don't usually work. I come in at the weekend sometimes when it's busy, but not much. Yeah. So kind of work-life balance.
Interesting, fascinating. So, one last thing I would like to think about is what I don't know if you can answer this, but where's the future of thermoelectrics? What would you hope for or anticipate in the next short term or long term?
Okay, I think the efficiency increasing a lot in recent years.
Oh, okay.
Yes. So if we can increase it more, then it will become competitive to other technologies.
Yeah.
For example, solar cell. You know solar cell, right?
Yeah, sure.
So now solar cell because the efficiency increased a lot.
Like people talk about them a lot. Yeah.
5% to 10% that's solar cell. But thermoelectric now it's like 1 or 2% of the efficiency.
Oh, so that's quite a difference.
Yeah, quite a difference. So if we can improve that, then we get more applications. Yeah.
If.
Yes, if. It's a big if.
So is there a path? Are you searching for that improvement, or is that moving?
There's a path. Not only me, but the researchers around the world in this thermoelectric community.
Okay, so we're hopeful for an increase. Yeah. Okay. Well, I think that's a fascinating view of your subject. It seems like there's a chance that it's going to build and grow, but we're searching for more efficiency.
Yes,
if I understand you right.
Yes,
yeah,
correct.
And it's got uses, very wide range of uses, right from some gaming you mentioned, and so right through to there's a spaceship somewhere outside the solar system which is
exactly
using it now. Yeah. Okay. Well, thank you very much for coming to join us. Thank you very much for joining us for today's podcast. I hope that was of interest and useful to you. As mentioned, if you'd like to find out more, we'll put up the details and you can contact Supri directly, or you can contact us as well for any more information. Look forward to seeing you on our next podcast.